Hello, so this is the last of the videos for the Pawsey Making STEM Real workshop. In this video, we're going to talk about visualization as communication. So remember that we talked about the basics of communication. We talked about what are we trying to say, who is the audience, how do we make it accurate, how do we make sure it's compelling, and what impact do we want to have on the audience. These are the basics of communication, and they apply very strongly to visualizations. It's important to remember that depending on the kind of information you're trying to visualize, tables and other text-based representations of data can be effective visualizations for small amounts of data, but they don't work very well for large amounts of data. It's very difficult to look at a large spreadsheet file and get a sense of what the data is doing without doing something to it, without doing some analysis or doing some visualization. So when we talk about visualizations, we're talking about graphs, we're talking about data displays, we're talking about visual grouping or organization of data, and we're talking about really any form of making data visual and making it easier to see. So even color highlighting of text can be a form of visualization. But what we always need to remember is that labeling is key. It's absolutely essential, and labeling is really it tends to be something that gets forgotten or neglected or poorly done. It's also something where you need to remember that you need to think about what your audience understands rather than what you understand. Sometimes when we label our visualizations, we label them with terms that really require an insider understanding of the data set, which is fine if the insiders are who you're trying to present the data to. But if you want to present to a wider audience, you need to think about what they understand and how you can label it to make sure that people understand it. So I'm going to show you an example now of using log graphs in COVID data, which is perfectly scientifically valid. It's a perfectly reasonable way to present the data, except that if you're presenting to the wider public, most people don't understand how to read a log graph, and even if they understand it, they don't intuitively read it. So we tend to look at a log graph and think it's linear, and it gives us a completely misleading idea of the data. So I really love Our World in Data for this kind of thing, because you can flip between linear and log graphs and it gives you a good indication of how the graphs are different. So focus for a moment on this line here, which is Germany's cases, which you'll see are spiking, and this is in the linear graph. Now let's put it to a log graph. Now Germany's cases, you can still see that they're spiking, but it's much less it's a much less dramatic rise. If you're presenting an exponential rise, it looks very different in a log graph to the way it looks in a linear graph. Now, just to be clear, to remember what the difference is between linear and log graphs, you can see the scale on the linear graph here goes up in regular amounts. So it goes up by 200, 400, 600, 800. When you click on the log graph, what we're doing instead is we're going up in powers of 10. So this is from 0.01, 0.11, 10, 100. And it just gives you an entirely different impression of the data. So while, as I said, log graphs are perfectly scientifically valid, they're not valid as a way of presenting data to the general public who aren't familiar with log graphs and don't understand the difference. Okay, so this is a short link that you might like to write down. It's a link to an activity out of the Computer Science Field Guide written by the good folks in New Zealand who have done a wonderful example of visualization that gives you a clear indication of how it changes depending on the kind of visualization you look at. Okay, so let's look at this visualization example. I'm going to click on Start, and remember that we're looking for the most common number in this data. First, we have a table which is unformatted, and I don't know, I think it was 4. Nope, the most common value was 2. Let's try it again. You can be trying to do this at the same time. Now it's highlighted, and I think it was 1, but not all the numbers were highlighted differently. Okay, so the highlighting did help me. Let's try it again. Pie charts are really hard to read. I think it's 3. Yep, I got that one right. Let's try it again. Last time I did the pie chart, I got it wrong, by the way, so pie charts are tricky. Okay, this in the bar chart, it's easy. It's 2. Try it again. Oh, now we've got a really big table. This is tricky. I think it was 8, maybe. It was not 8. It was 0. Let's try it again. We have some highlighting to help us this time. I think looks like 5, maybe. Yep. So we've got the heat map and 5. So the heat map helped. All right, pie chart. Okay, this time it looks like orange. Definitely orange. 8. Oops. 8. Okay, let's try it again. Bar chart. 8. Really obvious. So you can see when you're looking for the mode, the one that is just very, very clear is the bar chart. And if we continue, you'll keep getting larger and larger tables, and it gets harder and harder to do with anything except the bar chart. Gonna stop it there. So now I want to look at some very specific examples of visualizations and consider what you can read off the visualization and what you can't. So for every visualization, there are aspects of the visualization that make particular information clearer. Some information is much easier to get from some visualizations than others. Gapminder is one of my favorite ones because these bubble charts, which were pioneered by the folks who designed Gapminder, are amazingly powerful and incredibly effective. So what we're looking at here, the size of the bubble gives you population. If you hover over the bubble, you get the country that it's referring to. And we have a graph here, which is life expectancy against income. So what's very, very clear is, particularly if you hover over an item, you can get life expectancy and you can get income very, very clearly read off the graph. And when you press play, you can see the way these things change over time. And I particularly like, if you keep an eye out for what happens at around 1914, you can see some really interesting historical events play out in this data. So watch for it now. 1918, there you go. Did you see that crash? That was the Spanish flu. It's going to be really interesting to see how COVID plays out in this data. Okay, so you can see the color of the bubbles give you the region. And the size of the bubbles gives you population. They're labeled with names and you get all of that information. It also has a feature where you can select a particular country, like Australia, and it will highlight Australia and sort of fade out the rest. And if you then press play, you can see Australia's track over time through the graph. You can see it's pretty static for a long time and then it will start to grow. And you can track Australia's progress over time. So this is a really effective and powerful visualization that conveys a lot of information very, very clearly. By contrast, let's have a look at the climate stripes. This is a really interesting visualization because it's incredibly powerful. It shows temperature over time. This is just a quick illustration of it. Let's go down. If you look through the article, you can find that there are different versions of them. So you can see different ones. This is the one for the US. This is the one for Australia. But this is global, right? Between 1850 and 2018. And you can see these are representing temperatures. And you can see they get really, really hot. Think for a moment, though, about what you can't read off this graph. First of all, what year is this? No idea. Second of all, what temperature does this represent? Again, no idea. So there's no scale, there's no labeling, there's no axes, but it's a very clear indication that things are getting much, much hotter. So it's a very powerful way of showing one thing really clearly. Similarly, here we have a very famous visualization called the climate spiral. What this shows is the global temperature change from 1850 to 2020. And the interesting thing that you can see is that the lines become further and further apart as it gets further out in the graph. And we are, in some cases, even over the 1.5 degree mark, which is terrifying. And in some months we're not. Now, what you can't read off this graph is exactly what the temperature is for any of these points, or exactly what it is in January 1896. You can't easily see different years. You can't easily see precise temperatures. So again, what this is conveying very clearly is a trend rather than specific values. If you want specific values, you need an entirely different type of visualization. But this is really effective for conveying the pace of change, the fact that the pace of change is changing, is increasing, and the fact that we are approaching this 1.5 mark, and it's really scary. The last thing I want to show you about visualization is that spreadsheet defaults are often not your friend. In fact, often they make your graphs really misleading. This is a toy visualization in Excel. So let's have a look. We have 6 values there. The lowest is 91. The highest is 105. I'm going to insert the default chart using recommended charts. It's a bar chart, and that's fine. It looks like a reasonable representation of the data, and a lot of media outlets will publish this kind of graph as is, except maybe with the proper title. What is the problem here? What do you notice about the y-axis? This is really common. A lot of spreadsheets will give you the range of the data plus a little bit as your y-axis. So you can see it goes a little bit higher than the top value of 105 and a little bit lower than the bottom value of 91. But it looks like there's a really big difference between this one and this one, values 5 and 6. Now, if we change that scale and make it start at 0, so we set the minimum to 0 instead of 80, watch what happens to values 5 and 6 there. Suddenly they don't look nearly so different. In fact, the whole data set looks really relatively uniform. And that's because it is. But that first graph that we made it look as though there was a big difference when there wasn't one. It's a great way to mislead people, and it's a great way to misunderstand your data. And it's the default in a lot of spreadsheet packages. I'm pleased to see that Google Sheets doesn't do it anymore, but Numbers still does, Excel still does, and a lot of spreadsheet packages default to that. A lot of data analysis packages default to that. So a very important thing to teach your students is make sure there's a 0 on the scale. Now, there are, of course, occasionally times when when using the range of data or some other range does make sense and is a reasonable thing to do when you're looking for a specific feature of the data. But for the most part, it's actually wildly misleading. And it also means that it's very hard to compare one graph to another. If you've made 2 default graphs of 2 different data sets, they won't be using the same y-axis. And so you'll get very misleading results if you look at them and try to compare the size of the bars. So that's just one of the traps for the unwary in using spreadsheets to graph your data. So that's a few basic ideas about visualization to get you started on the road of getting your students doing visualizations in class and working with real data sets and making meaningful visualizations that actually convey the kind of information the students are trying to communicate. If you teach your students nothing else but that visualization is a form of communication and that all of the normal communication rules apply, then you've done really well. Thanks very much. Hope to see you at one of our Pawsey and ADSEI workshops, and keep in touch.